Assalamualaikum and a very good day to you all. In this video, I would like to share with you about first order partial differentiation. But before we go deeper, let's recap, okay, some stuff that we have learned back in differentiation. Okay, so asal warna hijau ni? Okay, black. Okay, back in differentiation. Okay, back in differentiation, let's consider a function, yeah? Y equals 3x cubed plus 4. Okay, so if we are going to take the first derivative of it by differentiate the function y, okay, with respect to x. Now what we get is the first derivative, which is what's that, 9x squared lah. Yeah, correct. And then if we keep do the same thing, okay, we keep differentiate. Okay, what we differentiate this time, this is the first derivative, okay, with respect to x. So from here we get the second derivative, which is 18x. Okay, now let's consider another example. X equals 2 ln y squared plus 3y. Okay, alamak, a little bit long. Oh well. So we take the differentiation with respect to this one, not respect to x, this one with respect to y. What we differentiate? The function of x. So we get dx dy equals 2 over 4 over y plus 3. Okay, and then we proceed. Okay, we do the second process. We differentiate the first derivative, okay, which is dx plus dx dy. Okay, I need to close it back. Okay, and then with respect to okay, with respect to y. So from here, what we get is the second derivative with respect to y, which is minus 4 over y squared, to close, 4 over y squared. Okay, plus, tak ada plus, 0 lah, 30 ni. Okay, so from here, this is what we have learned back in differentiation. Okay, so this one means we differentiate the function y with respect to x. Okay, this one means we differentiate the function dy dx with respect to x, to variable x lah. Okay, so same goes to this one. Okay, this one means that we differentiate the function x with respect to variable y. Okay, and this one means we differentiate the function dx dy with respect to y. Okay, so as you can see here, the function y has only one variable, x, while the function x contain only one variable, y. So what should we do if we have a multiple variable function? Okay, for example, z equals x squared y cubed plus 3x minus 2y squared. Okay, so if we're going to differentiate this kind of function, okay, we have to bear in mind from this differentiation that we have done previously, we have to be aware we can only differentiate a function with respect to a variable at a time. As we can see here, we differentiate dy dx and y with respect to only one variable at a time. Same goes to the function x. We can only differentiate it with respect to one variable at a time. So, from this one, we can differentiate the function z with respect to x. Okay, but since we have two or we differentiate z with respect to y. Okay, with respect to y. So that is why this kind of differentiation we call it partial differentiation, because we are differentiate them apart. Okay, one variable at a time. Okay, so let me rewrite the correct way of writing it. Okay, in partial differentiation, we have to use this kind of symbol, delta z, okay, delta x. This one means a difference, the first derivative of z with respect to x. Okay, so this one came from so this one so this one is the first derivative of z with respect to x. Okay, first derivative of z, or function z, with respect to variable x. Okay, variable x. So what happened to y? Okay, we treat other variables as constant. Okay, so same goes to when we want to differentiate z with respect to y. This one means first derivative of z with respect to variable y. It means other variable as constant. Okay, so from this function we can get either delta z delta x. That's the way of say it. Yeah, so this one. So from here we can differentiate it. We get, when we differentiate z with respect to x, we only look at the x. Okay, so from here we can other than that, other variable than that we consider constant. So in this case we have another variable y, so y constant. Okay, so y constant means we just treat them as constant, like 10, 5 or exponent or whatever. Okay, so this one we only differentiate x squared, so we get 2x. And then what happened to this constant? Since it's multiplied with the x squared before, we just multiply it again, y cubed. Okay, and then plus 3x, we differentiate, we get 3, we bring along the 3, right? So it behaves like a constant. Now in this case we have y only, there's no x, so the whole thing is a constant. So we differentiate constant with respect to x, we get 0, so 0 here lah. Or better still, no need to write. Okay, now, or we can differentiate it with respect to y. Remember, when with respect to y means other constant than y, which is x, consider other variable than y. Okay, sorry, we consider constant. Okay, constant. So let's differentiate z with respect to y. Before that, we padam object out lama y, then this one tambah, this one hitung semua. Okay, good. Blue, right? Okay, now we differentiate this one with respect to y. So the variable is here, so just copy paste along the constant, and then we differentiate the y. So y cube is 3y squared. Okay, now this one no y, so it's 0. Okay, this one y squared is the variable, so minus 2y squared, another 2y. Okay, so this is the differentiation, the first derivative of z with respect to y. Okay, so let's consider some examples. So let's see. So this is another way of writing it. This one we call z sub x. Okay, while this one we call it z sub y. Okay, z sub x is equals to delta z delta x, while z sub y equals to delta z delta y. So basically they're just the same thing, it's just that we write it differently. Okay, so let's proceed. So we have z here, so z sub x is, we differentiate the whole thing with respect to x. Okay, so let's see, 2x squared, x squared is the variable, so 2 multiplied by 2x. This one, this is the variable, so plus 3y put in front, x is 1, so 3y. This one, there's nothing, there's no x, so we 0. Okay, so we tidy it up, we get 4x plus 3y. Now let's move on to the second one, z sub y. Okay, z sub y, let's have a look. This one, there's no y, so it becomes 0. This one, there's y over here, other than that we consider constant, so just bring it along. So y, differentiate y becomes 1. 1 multiplied by the constant is the constant itself. Okay, next we differentiate, we have this y as the variable, other constant we copy paste, so differentiate y squared, we get 2y, and then we tidy it up, 0, nothing lah, so 3x minus 12y. Okay, so let's continue. This one is the another way of writing the differentiation lah. Okay, just almost the same thing. So let's find the delta f delta x. Okay, so this one delta x, remember with respect to x, with respect to x means other than that are constant, so x is the variable, we have y as the constant, copy the constant in front, and then x becomes 1 over here lah, multiply y also. Okay, this one we have x as the variable, ln x, we differentiate, we get 1 over x. Okay, next we are finding the delta f delta y. Okay, let's have a look. So we have so y is the variable, so x stay put, x, sorry, I forget to tidy this final answer. Okay, that's better. Okay, so x multiplied by 1 and then plus. Now there's no y inside ln x, So we consider ln x as a constant. Differentiate constant with respect to y is 0. So I tidy it up and then we get x. Okay. Okay, now let's have a look at the third one. Okay. We want to find u sub x. Okay. U sub x equals. Now, y is a constant. Okay. So, no need, just ignore. As you can see here, the variable is inside the exponent. So we are using the rule of exponential differentiation. So y is a constant, just copy paste. Now, how to differentiate exponent? Easy. We copy paste the exponent. Okay, and then we multiply with the differentiation of power with respect to x lah in this case. Okay, because we are differentiate them with respect to x, right? And then we multiply with the ln of the base. Since the base is e, might as well become 1 later. But that's fine, we will do simplify it afterwards. So this one is y. What's this? This one copy paste only. And then this one. Okay. Now, the x is the one that we want to differentiate. So what's left is 1 over y. Okay, and then ln e is 1. Okay, I simplify it further. Okay, I simplify it further to become, as you can see here, y can cancel out. Not really cancel out, they divide each other. That's why they be gone. So e x over y. So this is the u sub x. Okay, let's continue with u sub y. I think it doesn't fit. Okay, make this smaller over here. Put here lah. Okay, that's better. Okay, now when we want to find u sub y, okay, in this case we have to look where the variables are in the function. Okay, we have the variable over here also, and also over here. So we have a separate function on the left hand side and another separate function on the right hand side, and these two sides in the middle has operation, which is a multiplication. So what sort of rule that we have to use? What do you think? Why do you think for a while? Like 5 seconds. Done. You can pause the video if you want to think first. Okay, I hope you done thinking. Use your brain and all. Okay, so the rule that we have to use in this case is product rule. Okay, so product rule, we treat the one in circle as one function and the one in the box as one function. So we differentiate the front one, okay, with respect to y lah, of course. Okay, make sure they are the same. And then we just multiply with the exponent, no need to differentiate, plus, okay, y, no need to differentiate because we differentiate in front already. Okay, and then we differentiate whatever we have at the back with respect to y. Okay, now, so differentiate y with respect to y, we get 1 lah. And then multiply with the constant, we get ex over y. Plus, y is the constant, just copy along. Differentiate of exponent x over y with respect to y. Okay, so we have to differentiate an exponent. Very easy. The first step is copy paste the whole exponent with the power. And then we differentiate the power with respect to y. In this case, we want to differentiate with respect to y. Okay, and then we multiply with the ln of the base. This one will become 1 later on, so no need to worry much about that. Okay, so x plus y ex over y multiply. Okay, what we have here, we have minus x over y squared. Okay, so this is the shortcut. Okay, if you want to know what happened, I think it's helpful for you to move the y over here, right? I think it's easier for you to do it like this. Okay, and then since x is the constant, we only interest in differentiating the y. So what we have is okay, x stay put, so minus 1 bring in front, copy paste everything, power less by 2. Okay, you see, that's why we have x or minus x over y squared. Same thing lah. Okay, I rub this off. Now continue. Ln e is 1. Okay, no need to write also can, but I like to do one by one so that I can see the flow better. Okay, now so e power x over y plus y e x over y. Sorry, my bad. Minus this one negative y x e x over y square. Okay, you see here there are 2 y's down here, right? There are 1 y over here, can potong this one, leave 1 y. Okay, so we can simplify e x to the power of y, e to the power of x over y minus x e x over y. Okay, so that is the third example. Okay, let's consider this one. Wow, very long long question. Okay, so find the values of this one nothing lah. Okay, this one just the same thing, delta f delta x. Okay, easy. This one 2x with respect to x, remember this one with respect to x, 3y, y become 0, minus 1 become 0 also. Okay, so at 4 minus 5, okay, the delta f delta x with a line 4 minus 5, we can also write like this. Okay, this whole lot means the value of delta f delta x at point 4 minus 5. So this is a fancy way to write it. Okay, might be useful for you to apply later in your working. So just gantilah. Okay, and then plus 3 minus 5. So we get berapa ni? 8 minus 15 minus 7, right? Minus 7. Correct. Okay, that is the first one. Now what is the second one? Second one, we have to find the delta f delta y. Delta f delta y is x squared 0 3xy plus 3x. Remember, y is the variable now. Okay, and then this one y plus 1 minus 1 becomes 0 lah. Okay, so same thing, we want to find the value, right? So delta f delta y, line bracket 4 comma minus 5 equals 3x. X is what? 4. Okay, plus 1, so equals 13. Okay, so the value is minus 7 and the other value is 13. Okay, so let's consider last example. Okay, so as you can see, this one a little bit different way of writing, right? This one is the same thing with the previous example I've made. The way of writing is it means delta f delta x with a line over there at 3 1. So they are the same meaning. just different way of writing. Okay, now as you can see here, this one and this one is a we are more likely to use quotient rule, right? So I want to cheat lah. Okay, I want to use my cheat code by changing the function. Okay, not really changing lah, we just change the appearance a little bit. Okay, so if I do it like this, I will use product rule. If you want to retain whatever, if you want to retain the shape like this, then you have to use quotient rule, which I really hate so much. Okay, so up to you. Okay, you want to use whatever you want to use, you use. Okay, as long as the value correct. Okay, so so f sub x is for this one product rule lah in this case. Okay, in terms of x, with respect to x, we need to use product. With respect to y, I don't think so. Okay, so we differentiate with respect to x, the first thing, and then we just multiply with the bracket, plus the first bracket, no need to differentiate anymore, minus 1. Good. And then I proceed, and then 2x minus 1 minus 1 plus 2x multiply. Okay, this one minus 1, copy paste, minus 2. We differentiate the content of the bracket. Okay, then 2x minus y minus 1 plus 2x bracket. Maybe I put the negative in first, and then x minus y minus 2, power minus 2. Now differentiate x minus y with respect to x. We get 1. This one minus 0, which is 1 lah. It's like nothing lah. So we simplify, we get 2x minus y minus 1 minus 2x, x minus y minus 2. So f sub x at 3 1. Okay, 3 1. So what we have is 2 3 minus 1. Okay, I think in this case it's better for me to 3 minus 1, yes. And then 2x. Okay, 3 minus 1 squared. I change it back. I change the form back, easy to calculate. Okay, 2 over 2 is 1. 6 over, what's that, 4? 4. 4, so minus half. This one is minus half. Okay, this we continue with f sub y over here lah. F sub y, because I forget the name. Okay, so maybe I copy over here first, 2x, x minus 1 minus 1. Okay, so this one, we want to find the differentiation with respect to y. As you can see here, we no need to do product rule, because only the inside of the bracket has variable that we want to differentiate. Okay, so this one we consider as a constant lah. Constant. Okay, x also. Allah, I want to use blue color. So this one constant, this one constant. So might as well continue. So constant, copy paste. Okay, and then this one we use power rule. Okay, so power rule says that we bring power in front, copy paste the whole bracket with the power less by 1, and then we differentiate further the content of the bracket. Simple. Okay, so 2x, alamak, put negative in front lah, like that. Yes, better. X minus y, and then minus 2. And then, you see, we differentiate x, y with respect to x. Sorry, with respect to y. Okay, we differentiate x with respect to y becomes 0. Okay, and then we differentiate minus y with respect to y, we get minus 1. Okay, so 0 minus 1 minus 1 minus 1 multiply, alamak, tambah balik. Okay, so 2x, x minus y, 2. Okay, so fy 3, 1 equals, I change it back, easy to calculate some more, like that. So we have 3/2, correct, 6/4, correct. So this is the value. Okay, I think that's all. Thank you for your time and attention. Assalamualaikum, have a good day.